Okay, so we're going to go through the test review for the College Algebra Chapter 8 test. It's coming up on Friday. So here, we're just going to go through it. These first three, we're looking to see if they're arithmetic, geometric, or neither. Arithmetic is when there's addition or subtraction that's repeated, and geometric is when it's multiplication or division. If I look at 64 becoming 16, that's a subtraction of, was it 48? It doesn't look like I'm subtracting 48 each time, but it does look like division by 4. Now if I'm dividing by 4, that's the same thing as multiplying by 1/4, and I can check if I take 16 divided by 4, it's 4, 4 divided by 1, or 4 divided by 4 is 1. So this is repeated division, which makes it geometric in nature. This next one goes from 3 to 0 to -3 to -6 to -9. It looks like I'm subtracting here. It looks like I'm subtracting 3 again and again and again. So because it's repeated subtraction, I'm going to call this arithmetic. Okay, and then this third one over here, at first glance it might look like it's just nothing. But if you think about it in terms of the decimals or the fractions, this fraction, whole number thing can be a little confusing. So this might be better to be 0.5, 1, 1.5, 2, 2.5. It looks like I'm adding a half each time. So this is also arithmetic. Now does that mean that there won't be a neither? No. Does that mean you won't get two geos? No. It's just a scenario. So you need to be prepared to look at each of them individually and make a decision about whether it's arithmetic, geometric, or neither. And neither means it's not the same addition each time or subtraction, and it's not the same multiplication or division each time. You may see a pattern, but if it's not this type, then it's going to be throwaway. To find the 97th term, we're literally going to take 97 and plug it in to our equation here. So a sub 97 would equal -2 times 97 plus 60. I'm just going to grab my calculator for exactness. It'd be -2 times 97 plus 60, and that gives me -134. Okay. So now on number 5, I'm supposed to find the sum. Now the reason I tell you it's not geometric or arithmetic, there are example equations that you can use to do arithmetic and geometric sequences and series, but this is not one of those, so there's really only two ways to do it. You can either put it into the calculator, or you can do it by hand. I'm just going to do them all by hand. You would do it by putting 2 in, and then 3 in, and then 4 in to this equation. If it was 2 to 5, I'd put 2 in, then 3 in, then 4 in, then 5 in. You do as many as you have numbers, starting at the lowest number here and working your way up to the bigger number up here. So if I put 2 in there, that's 3 times 2 cubed minus 10 plus 3 times 3 cubed minus 10 plus 3 times 4 cubed minus 10. All of this should add up to give me my answer. So 3 times 2 to the third minus 10 is 14. So I've got 14 plus, and I'm just going to arrow up, grab this and change it to a 3 there. That gives me 71 plus, and I do it again, whoops, with a 4 instead of the 3. Now obviously if you know how to use the calculator to do this in one quick step, that's awesome, and I'm all for it. But I'm going to add that to my 71 and my 14, and that gives me 267. Okay, so again, if you know how to do this by some other method, feel free to use that other method. It's totally okay. Alright, now when we get to 6, 7, 8, 9, you're asked to write the equation. Now over here I'm going to write my couple of options. If you're using arithmetic, it could be a sub n equals the gap times n plus compensation, or a sub n equals a sub 1 plus d times n minus 1. I'll show one of each of those, and then if it's geometric, you would do a sub n equals a sub 1 times r to the n minus 1. So you're going to have to choose one of those equations based on the type of problem you're looking at. Going from 24 to 48 would be adding 24, but from 48 to 96, that's adding 48. So I'm not adding the same thing each time. I think this is probably geometric. Because it's geometric, I would need to know the first term, which is 24, and I would need to know how I get from one term to the next. So because I know that the first term is 24, all I need now is what's the common ratio. What multiplication moves me from one term to the next term to the next term? And it's a multiplication of 2. So in this problem, all I have to do is the first term, 24, times my multiplier, which is 2, to the n minus 1. And I'm done. On number 7, I notice that it's 2 becomes 4, becomes 6, becomes 8. It looks like it's just a plus 2 each time. So if I'm adding 2 each time, that makes it arithmetic. On this one, I'm going to go ahead and do the a sub n down here. So a sub n equals the first term, which was 2, plus the difference, which is 2, times n minus 1. This would be okay, except I really need to clean it up and make it look a lot better, so I'm going to distribute. Get 2 plus 2n minus 2. This term and this term should always be combined if possible. Turns out in this problem that the 2 and the negative 2 actually cancel each other out. So my final answer would be a sub n equals 2n. To prove that we've done this right, if you put 3 into this equation, you get 6, which is the third term. That's exactly how these are supposed to work. Again, you don't have to prove it to yourself or me, but if you want to know that you've done it right, that's how you check. When you're told that there's a common difference versus a common ratio, knowing that the difference is the arithmetic and that the ratio is the geometric. On this one, I'm going to go ahead and do the gap times n. The common difference is the gap, so this would be 3n. And I always do plus compensation, okay? The way that compensation works is you have to plug a number in for n and then get the expected result. This problem says that the fifth term is 25, which means if I put 5 in here, I'm supposed to get 25. But when I put 5 in here, I get 15 plus comp. Now, I put 5 in, I got 3 times 5 is 15. I'm supposed to be getting 25, because that's the number that the fifth term is. Well, the only way I get 25 from this is if the compensation is 10. So then my formula would be a sub n equals 3n plus 10. And that's it. Now, if you do the other form that we did up here, you'd get the exact same thing. You just have that simplification step to do where you distribute. Okay? Same answer either way, though. With a common ratio, we're looking at this geometric type, which a sub n is always the first term, which was 25, times the common ratio, 1/5, to the n minus 1. The geometric ones are really easy to put together. Just understanding how they're structured is really important. Now, when I come to these two down here, we're trying to build the summation. The way we do that is by doing the exact same thing we did on 6 through 9. We need to first build an equation. That's what goes here and here. So if I'm looking at this, this is going up 3 each time, plus 3, plus 3. So that means that I would have, we'll do it by the gap method, 3n plus compensation. Now this 3 over here is the first term. So if I put 1 in for n, I get 3. Well, that is the first number. So in this case, there is no need for compensation. The compensation would just be 0. So one way or another, whether you use the compensation method or use this method up here, you should get 3n. Now we have to determine what goes on top and bottom of our sigma notation. Because we built the equation, we'll assume it starts at 1. That will always be true when we're building. Now, in terms of the top number, you can say it's two ways. It's either A, if you're starting at 1, it's how many terms there are, which there are 6. The other way to look at it is, what number would you plug into this equation here, the 3n, to get your last term, which is 18? Well, 3 times 6 is 18. If I plug 1 in, I get 3. 2, 6. 3, I get 9. 4, I get 12. 5, I get 15. And 6, I would get 18. And I would add all of those up, as I demonstrated earlier on question number 5. 11, same idea here, but it's division by 2, division by 2. So this is a geometric, which is the first term, 60, times the ratio. Well, I'm dividing by 2, but that's the same as multiplying by 1/2 to the n minus 1. Again, when we build this, we assume it goes from n equals 1 to however far out we're going. This only has 3 numbers, but then it has that ellipses, which means goes forever. That tells me that I'm looking at an infinite series. Okay. We've just got 4 more problems, and they are all things that could go put straight into the calculator, but I'm actually going to use the formulas and do them by hand so that you have that backup method for all these. So for arithmetic, the rule is n times a1 plus an all over 2. Now if you're doing an arithmetic one, they can go straight into the calculator. Just typing them in correctly is all you have to do. Now an arithmetic one would look like a line equation, which would be 13 and 14. Both of those are arithmetic in nature. To do this, I first have to figure out how many numbers there are. Well, to go from 1 all the way up to 10, that's 10 numbers. If you think about counting from 1 to 10, you'd have 10 numbers. So this would equal 10 times. To get the first term, I have to plug the first value here in. If I plugged 1 in here, I get 6 times 1 is 6, minus 14 is negative 8, plus, to get the last term, I have to plug the top number in. 10 times 6 is 60, minus 14 is, I want to say it's 46, and all of that divided by 2. So to get this solved out completely, we're going to take negative 8 plus 46 divided by 2, and then we'll times that by 10, and that gives me an answer of 190. Now if you did this in the calculator and you got 190, you're good to go. Over here at number 14, similar idea, but we have to be a little careful here. When we go from 5 to 9, the number of numbers is not 4. And if you aren't sure, you're going to count with our fingers. 5, 6, 7, 8, 9. That's 5. And so the number of numbers in this problem here is going to be 5. I'm going to times that by. The first term comes from taking 5 and plugging it in. 5 times negative 2 is negative 10, plus 8 would be negative 2, plus getting the last term comes from plugging the last number in, which would be negative 2 times 9 is negative 18, plus 8 is negative 10 all over 2. And so if we take our negative 2 plus a negative 10, that's negative 12, divided by 2 is negative 6 times 5 is negative 30. Okay. Oh, excuse me. Okay, there we go. I had a little issue with my... Ooh, don't get seasick. Okay. These last two are geometric. And with geometric, there are 2 types. A standard geometric summation will equal a1 times 1 minus r to the n over 1 minus r. And an infinite geometric equals a1 over 1 minus r. So I'm going to go ahead and I'm going to do this non-infinite geometric. I can tell it's geometric because it has an exponent here. The rule is that you need to first find the first term. I find the first term by putting this 2 in as an exponent. If you put negative 4 times 2 raised to the 2 minus 2, you're going to get that a1 is negative 4. So I have negative 4 times 1 minus, r will always be in this parentheses, 2 to the and here I'm counting from 2 to 13. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 12 numbers here. So 2 to the 12th over 1 minus 2. Okay, so this is important how we put that in there. I'm going to do 1 minus 2 raised to the 12th. I'm just going to do that part. Now I'm going to divide it by, what is 1 minus 2? Well, 1 minus 2 is negative 1, so I'm going to divide that by negative 1. And then I'm going to times it by negative 4 to get negative 16,380. And the last problem is our infinite geometric. So far, all three of these, 12, 13, and 14, could have been put into the calculator using summation notation if you paid attention and done it in class with us. But 15 can't be, because it has this infinity symbol here, and our calculator just doesn't have an infinity button. So we're going to come over here and we're going to work this problem down. Now, it's extremely important that you take time to think about each of these things. A1 is not always this number in front. It is if we built it, but we didn't build this equation, or you didn't, Mr. Welch did, so you can't trust that. You do need to plug 1 into there. And so I'm going to do that. I'm going to type negative 2 parentheses 1 over 4 raised to the, and it's 1 plus 2, that's to the third. It gives me this, oh, sorry, that's not supposed to be negative. Ignore the negative for a second. It was just regular 2. If we go ahead and do the math, frac, this is where my answer of, imagine that's positive. The a sub 1 is 1 over 32. Now, if you want to put the decimal point 0.03125, at this point it doesn't matter. We're going to get an answer and try to turn that into a fraction. But then that's over 1 minus r. Now, r does always come from the parentheses. So 1 minus 1/4. So this is 1 over 32 over 1 minus a quarter is 3/4. Again, if you want to use your calculator for that, that's fine. What I don't want you doing is taking 1 out of 32. Okay, you get that number. If you divide by 3/4 right now, it's going to be a disaster. You either have to do some flipping times or you have to use parentheses. This is not going to work out well. You also don't want to divide it by 1 minus 1 over 4, because if you don't have parentheses, it's not going to read this right. So it's really important that you have a good method for doing this. I know that 3/4 is 0.75, so I'm going to divide by 0.75. And I'm going to get this number, and I'm going to math frac that, and it's going to give me 1 over 24. And that's my sum. Okay, so that all being said, if you have some questions, come in, talk to me. I'd be glad to help you and see what we can do to make it better for you. All right? Thanks and good luck.